Welcome back guys to the channel. So in this video we are going to take a look on an image segmentation technique from which we are going to extract some dominant colors from a picture. Okay, so this is going to be a very fun video. Like, here's the picture that we have given, and this is the end result, which the dominant colors. Okay, so this is how the thing is going to work. So let's get into the video now. Okay, so one thing we have to keep in mind, like when we are dealing with this image segmentation and all the image thing, we are going to use a library in Python, which is the computer vision, which we commonly call as OpenCV. So here we have imported like OpenCV here, import OpenCV2, like CV2, and then we have taken it numpy. So why we are taking numpy here? Because the image that we are importing in Python, here in our case, or like in general, so the images are stored in format of a array. Okay, so numpy here help us to perform some operations over those arrays, which are simply the images. Okay, then we have taken matplotlib. Of course we have to plot things. Okay, so matplotlib will be useful in plotting things. So first we are going to import the image by using cv2.imread, which means image read, and here I've given the location of the image, then we have readed it. One thing to keep in mind here also, like when we read an image from cv2 through cv2, so the cv2 by default reads it as a bgr image instead of an rgb image. So by using the cvt color, we have changed the spectra to an RGB format. Okay, so this is how we can get the original image, because we are actually dealing with the colors, so we have to keep this thing in mind here. Okay, so here I have printed the image, and here it looks like this. Then what I have done here is I have converted a 2D array into an 1D array to make the operation easy for me. Okay, by using like reshape -1 comma 3. So here 3 will represent the RGB band, and -1 will the two dimension will also be there. Here you can see here the shape of the image before performing the reshape experiment. So it comes out to be 719 into 1600 comma 3. 3 is the RGB band, so these are the dimension in 2D. Then we have reshaped it by using -1 comma 3. So the final shape of the image, we got it like this 1150. That means it has been multiplied, and 2D two-dimensional image is converted into an one-dimensional array here. Okay, so by using -1 here, we have converted it, so it will be like easier for us to analyze all the data points when it is in one dimension. Okay, yeah, like here we can confirm 719 times 1600, it comes down to 115. That the original dimensions of the image. So now the real implementation parts comes into play. So here we are going to use a clustering method, which is k-mean. So I'm not going much into detail of how k-mean works, but or something. So here's the documentation where you can go through with the simple implementation and how the k-mean algorithm works. But on a like on surface level, so k-mean basically creates clusters and then mark the centroid there for each cluster, and then calculate the distance of the points, and then dedicate the labels. So how this is how like k-mean work. Okay, so it firstly creates a clusters, and then it marks the centroid, then takes some distance from there, and then label the following points. So this is how k-mean work, and for detail you can go through the documentation. So here I have given the dominant color 5. So here you can play around with this and change it. So we'll see, like in end we'll see how this is going to affect the image. So here I have implemented the algorithm, fitted the model, and these are the coordinates in the RGB band that we have got for the 5 dominating colors. This is going to be in R. First column is going to be in R, then B, then G, and these rows will represent following like colors, dominating color that we have extracted. Okay, now what I've done here is I have printed out the colors that we have extracted. So for that I have used subplot method, and I have taken a base with zeros that it will be totally nil, and then over that our colors are going to be placed. Okay, so these are the print plt.im show a, that means we are getting this thing here. Okay, then we have a pixel size of this, so pixel size comes out to be as same dimension that we have discussed earlier. And these are the labels associated with the image that we have, like data point that we have collected. So these are the labels extracted with it. Like the first three are in zero cluster and the last three are in first cluster, so we can like easily identify, and its shape is compatible to the shape of the whole data set, like 15004 and this thing. Okay, so like now let's get to the implementation part, and we have to like get the original image back from the analysis by only having the dominant colors. So this is the code that I'm using here, and I have got this image which is showing me the dominant colors, the five dominant colors of the image that we have extracted. Okay, so let's play around with the dominating colors. Okay, so if I'm going to increase the value of dominating colors, it is going to give me a much more resolved image. Okay, like the image will be much more sharp and much more clear by increasing the numbers in dominating colors. Like now I have given it 10, so here you can see we have extracted 10 dominating colors, and this is the image. So here you can see, if you will compare with the earlier one, so here we have much more feature and much more detail. So let's try it with a 2. Let's see how the image is going to see what are the two dominating colors here. So these are the two dominating colors. Okay, I think this is it. That's all from this video. Hope you like the method here, and stay tuned to the channel, because we're going to make such kind of videos much more frequent now. Okay, and we'll look into the physical computation thing and the image processing thing. Okay, so stay tuned to the channel. So see you guys in the next one then. Bye. You said